All right, so we're going to keep talking about functions, and we're going to start doing something called function operations and composition of functions. And what that basically means is we're going to take more than one function. So we're going to have an f of x, and we'll also have some g of x, some h of x, and these are just other functions. It doesn't matter if it's f, g, h, what the letter is. It just means we're going to be working with more than one function at a time. Some of the things we're going to do is we're going to add two functions together. We're going to subtract functions. We're going to multiply them, and then we'll also divide them. And when we do these things, when we add functions together, multiply them, subtract them, divide them, for each new function that is produced by adding two functions together, the domain consists of all those values of x that are common to the domains of f and g. So we take the domain of each function and we see what they have in common, and that's the new domain of the new function, and we'll see what that means in a minute. One little restriction to that, the domain of the quotient function, which is when we divide. So domain of the quotient function is restricted because we have to exclude any values that make the denominator 0. But you know that already. Let's take a look at what this means and what we're actually doing. So here we see f plus g of x. So if you look up at the top section, you can see that f plus g of x is equal to f of x plus g of x. And I'll try to use different colors here to keep it nice and neat. So f of x is x squared plus 4x plus g of x is the square root of x plus 2. And it's very important when we do these that we always use parentheses and keep things organized and keep things nice and neat. We make sure that we do everything within a parentheses before we do anything else. So now there's nothing we can do with this parentheses in this case, so we can go ahead and drop it, and we can write x squared plus 4x plus the square root of x plus 2. And there's nothing else we can do, so that is our f plus g of x. Now it says find each function and its domain. So the domain for f of x, that's this one here. This is a parabola, so that domain, you know, is negative infinity to infinity. Our g of x, you know, that's a square root function, so that we can't have a negative 2 where that x is, because that would make this 0, so anything less than negative 2 is no good. So our domain for here goes from negative 2 to infinity. So for our f plus g of x, our domain has to be what these two have in common. So they both go to infinity, but this one stops at negative 2. So the domain for our new function is going to have to be negative 2 to infinity, because that's all they have in common. So there's our domain. All right, so let's do f minus h of x. So we'll start with that is f of x minus h of x. And we'll see what that comes out to be. So f of x again is x squared plus 4x minus, remember, parentheses, h of x, just 3x minus 5, close our parentheses. And before we do anything, we want to make sure that this minus sign gets distributed, so that when we rewrite this, we have x squared plus 4x minus 3x plus 5. Now we can combine like terms and simplify this, so it's x squared plus x plus 5. So that's our function, that's our f minus h of x. And we look at our f of x. We knew the domain for that was negative infinity to infinity. We look at our h of x, which is just a line. So h of x domain is also negative infinity to infinity. So that lets us know that our f minus h of x domain is still negative infinity to infinity. So not too bad. Keep moving right along. We're going to do f times h of x, so that's f of x times h of x. So that's going to equal, parentheses, x squared plus 4x, close our parentheses, times 3x minus 5, and close our parentheses. So this is just like any other problem we've done before. We have to do FOIL. So we'll do first, outside, inside, and then last. So that's 3x cubed plus 7x squared minus 20x. And our domain, well, the domain of f of x was negative infinity to positive infinity. H of x is negative infinity to positive infinity. So our domain for this function is going to be negative infinity to positive infinity. All right, so now we're going to do the quotient. The quotient's a little bit different in that we can't have any zeros on the bottom, but we're going to do h of x divided by f of x. So that equals 3x minus 5 divided by x squared plus 4x. Okay, so the domain for this one is negative infinity to infinity, and the domain for this bottom is negative infinity to infinity. But we got to rule out what would make this 0, because this can't be 0. So to do that, we take the bottom and we say that it has to be not equal to 0. So we factor it. So we have that x can't be 0 and x can't be negative 4. So our domain is negative infinity to negative 4, union negative 4 to 0, another union 0 to infinity. So what we did was just take out the negative 4 and the 0 from our domain. So now we'll move on to something called composition of functions. The combining of functions, called composition, is a result of one function being used to evaluate a second function. Okay, so what we've been doing is adding and subtracting and multiplying and dividing them, which is pretty basic. It's kind of like combining like terms. What we're going to do now is called a composition, and it's where you take a function like f of x and you take another function g of x and you find f of g of x. And all that means is that we're going to find f of g of x. It may look confusing, but it's really not that bad. So we'll have our f of x and we'll have our g of x. And since we're finding f of g of x, that means we're going to take our f of x, which is x squared plus 1, and we are going to put g of x everywhere there's an x. So what that's going to look like is we're going to put x minus 4, our g of x, squared plus 1. So we're doing whatever g of x is when we plug it in for x, so g of x squared plus 1. Okay, x minus 4 squared is x squared minus 8x plus 16 plus 1 gives us x squared minus 8x plus 17. And so that's it. That's our f of g of x. So now we're going to go and do g of f of x. So we're going to do g of f of x. And that is going to be x squared plus 1, because we're going to put f everywhere there's an x in g of x. So minus 4. So x squared plus 1 minus 4 is x squared minus 3. Not too bad. So f of g of 2, that is f of g of 2. Well, one way to think about that is we already did f of g of x, and that was x squared minus 8x plus 17. So f of g of 2 is 2 squared minus 8 times 2 plus 17, which equals 5. Okay, so this one will be a little more tricky. We're going to do f of x, g of x, and we're going to find f of g of x. So we're going to do f of g of x. So everywhere there's an x in f of x, we're going to put g of x. So we're going to write out f of x. We're going to do 1 over x squared minus 9 plus 1. And so what that will equal is 1 over x squared minus 9 plus 1, which is 1 over x squared minus 8. And that's all we can do. So now we've got the new f of x and g of x. So we're doing f of g of x. So f of x, g of x, and we're going to do f of g of x. So everywhere there's an x in f of x, we're going to put g of x. So we'll do square root of x minus 3. That's our g of x plugged into f of x is going to get squared minus 2. So the square root of x minus 3 squared is just x minus 3 minus 2 is x minus 5. And that is compositions of functions.